Hello everyone, this is Rajiv Sanaki, Department of Civil Engineering, Jain Polytechnic, Belgavi. So in today's lecture, we'll be completing the last portion, that is the problematic part in design of lintel in unit 5. So the content here is design and detailing of lintel, that is the problem. So design of a lintel, so so here in this case, what we are doing is the length is given. We are determining the effective depth, that is after substituting we get 240 mm. Overall depth is equal to effective plus cover. So the cover what we are using or assuming is 35 mm. So effective cover is equal to 35. So overall depth 240 plus 35 is 275. Now width we are taking as 230. Effective span is equal to it should be the least of the two. So substituting the values in those two, we get L is equal to 2.63. Load and moment calculation. For transfer of loads to the sides by arch action, height of wall above lintel, that h is greater or equal to 1.25 h. So h is equal to 3 meter. So substituting the equations here, finally we get W is equal to 13.22 kilonewton. Moment due to masonry load, M1 is equal to WL by 6. Substituting here we get 5.79 kilonewton meter. So self weight of lintel is equal to W is equal to B into overall depth into density of RCC, that is rho. So that is 25. So substituting all the values we get 1.58 kilonewton meter. Moment due to self weight, that is M2. M1 we have calculated. Now WL square by 8. Substituting we get 1.36. Now we want the total bending moment. M is equal to M1 plus M2. We get 7.15 kilonewton meter. The ultimate moment is equal to multiplying the bending moment into 1.5. We get 10.73 kilonewton meter. Now check for depth. So it depends on the Fy. That means the choosing the equation depends on the Fy. So here Mu is equal to 0.138 FCK BD square. So determining the depth required, we get 130, which is lesser than 240. Hence the design is safe. So design of the tension reinforcement, that is AST. Substituting the values in the equation, we get 130.24 mm square. Providing 10 mm diameter bars, we get 78.5. Therefore number of bars is equal to 2 numbers. Now design of shear reinforcement. Shear force V is equal to WL by 2 plus W by 2. Substituting the equation values in the equation, we get 8.68, that is shear force. Now ultimate shear, multiplying the value of shear into 1.5, we get 13.02. Now shear stress tau is equal to VU by BD. VU we know, B we know, D we know. So substituting we get 0.235 Newton per mm square. Therefore AST is equal to 157 mm square. Percentage steel we have to calculate. Substituting values 0.28, we get value. Now for tau C value, refer table number 19 IS 456. Therefore tau C is equal to 0.37 Newton per, which is lesser than the value which we got. Therefore entire shear is taken by concrete alone. Hence providing nominal shear reinforcement, provide 6 mm diameter bars. Now ASV, that is the area of two leg vertical stirrups, we have 56.55 mm square. Spacing of stirrup should be least of the three. These conditions substitute all the values in these three conditions, we get 6 mm diameter 2 LVS at 180 mm center to center. Finally, after designing, you can see the diagram here. Which shows the longitudinal steel as well as the main steel and the lateral ties. Thank you.